As I told you in the introductory session, that Terraform is used by many different providers, or you can use many providers like AWS, Google Cloud, Azure, or not only cloud. There are few other things also that Terraform supports. It has many providers. So if you scroll down here, you can say registry.terraform.io. Come to this site. These are featured providers, the main providers: AWS, Azure, Google Cloud, Kubernetes, Oracle Cloud, Alibaba Cloud. So let's go to AWS, documentation. So all the resources that you want to use to maintain your AWS infrastructure are available here. On the left hand side pane, if you see, there are a lot of services, AWS services like EC2. So we used EC2 already, right? So EC2. And in this section, you have the resources: AWS AMI, copy AMI, to take snapshot. The one that we used was this AWS underscore instance. Let's click on this. So you can see example usage. You should really scroll down to see better example. Okay, there. Now, yeah, there is a resource for AWS VPC, my VPC, and give the CIDR block. And this resource will create a VPC. You want to create a subnet in the VPC, AWS underscore subnet v in this VPC. Right, so we are referring to this VPC that we created. Right, then there is some networks interface that is getting created. So there are really multiple resources in one file here. And AWS instance, the one that we used, right? So we mentioned AMI ID, instance type, the network interface you want to connect to. All right, so you're right. In this exercise, we are going to see multiple resources. And the good way is really to distribute them into different files. If you see AWS key pair, see that we use that public key, and we have not given the entire key. We use the file function. I'll also show you functions. So you can see arguments, attributes that you can pass to a resource. So in this exercise, we're going to create VPC, we're going to create security groups, and we're going to launch instance in the VPC that we created. And also we're going to use the security group that we have created. So let's see our resources one by one. First, VPC. So I'm going to close that. I can make a search from here. I can do say VPC. And you have the VPC resource, AWS underscore VPC. So we're going to use this resource to create our VPC. AWS underscore subnet resource to create our subnet. So we can see easily example, and you can also see the arguments and the attributes that you can pass in that. Right? When you create a subnet, you have to mention the VPC ID, right? So that should be the format, and the value should be a VPC ID. So we're going to create 3 public subnet and 3 private subnet by using this resource. We'll also create internet gateway. So there you have AWS underscore internet gateway, and that's how you can create an internet gateway. Route table, AWS underscore route underscore table there. So you can create route table like that. So you really don't need to remember all these things. Everything is there in this documentation, and the arguments and the attributes that you can pass. Also, this AWS route table association. So how we are going to associate our subnet with the route table. So we say the resource name, we give the subnet ID, and we give the route table ID. Okay. So these are the resources we're going to use in our vpc.tf file. So let's create our next exercise now. Okay. So in my Sublime text editor, I'm going to say new folder, exercise 6. First thing we'll do is we'll create the providers.tf file. Providers.tf file. Let's save that. We'll create variables file because we are going to refer to some variables. So we'll have the region variable, zone variable. We'll have AMIs, user variable, also the public key name. So that should be our key, devkey.pub and devkey. We'll copy the same key from the exercise 5, or we can just regenerate it. In any case, let's just delete the existing key that we have. Okay, it's not there. Okay, but just validate if you have not destroyed it. The key should be there. It's not there anymore. Okay, so let's also copy our key from exercise this to exercise 6. Okay, we have the key here now, the private key and the public key. Okay, now let's create the resource file for VPC. We'll name it as vpc.tf. Oops. Control save. vpc.tf. Okay, with AWS underscore VPC resource, the name of the VPC, the resource will be Dove. Cider block, instance tenancy default, enable DNS support true, enable DNS hostname true, and the tag. So these are the properties. Again, you can get that from the documentation. Oh, sorry, the attribute. We call it attribute here. Okay, then we are going to create the subnet. AWS underscore subnet name. First public subnet will create VPC ID. Now we are referring AWS underscore VPC, that resource, that name .dove .id. So once this resource gets created, it will have an attribute called ID, and that we can refer it here. So this subnet will get created under this VPC with cider block this. Map public IP on launch true. So if you launch instances in this subnet, it will have a public IP. Availability zone, we will change that. We will define our variables. We have zone 1, like that we'll define zone 2, zone 3. So we'll copy this, paste it. Okay, so we'll say zone 2 is US East 2B. Zone 3 is US East 2C. Okay, make sure you confirm the zone name from your AWS account. In EC2 dashboard, you can check that. Let's save the file. So we'll say here var.zone1. var.zone1. Okay, like that, we are going to create 5 more subnets. Okay, so the public subnet 2, things that are different, cider block, and the zone, we'll change it to var.zone2, and then the tag, that's second subnet. Third subnet, again same resource, cider block changes, zone is different, and of course the tag. So we're saying these are 3 public subnet. Now we have 3 private subnet also. Private subnet 1, cider changes, zone, it's going to be in zone 1. Subnet 2, again cider changes and zone 2. Third private subnet, cider changes and zone 3. So you can really check from the documentation as well, AWS underscore subnet, and you can check the arguments that you can pass, availability zone or availability zone ID you can pass, cider block, map public IP on launch. So whatever you need, you can fetch that, VPC ID, and as per your requirement, you can put it in your resources. Next, we'll create internet gateway. Okay, so that's the resource type, resource name, VPC ID. That's it. Internet gateway gets created in the VPC. So we have to join our public subnet with the internet gateway. So we have to create the route table. So we can check the resources of the route table, AWS underscore route underscore table. Alright, so resource name, resource type, resource name, give the VPC ID, and then inside that you have route. So you have to say, if the traffic is destined to this, then it can forward it to this particular gateway. Right? And also you can give tag. By using this information, we'll create our resource. So we're creating a route table named this VPC ID we're referring, and we're saying IP address that wants to go, the packet that wants to go to any IP addresses can be routed to the internet gateway. Okay, so the gateway we have creating over here, right? .dove-igw.id. So that should be good for the route table, but we also need the route table association. We have to associate our public subnet with this route table. So we have the resource AWS route table association, and it's very simple. You just mention the subnet ID and the route table ID. So we have to really give it 3 times because we have 3 subnets. Okay, so AWS route table association, a resource name, subnet ID, the subnet that you've created previously, route table ID, the route table ID that we have created previously. Okay, so this is for public subnet 1, this is for public subnet 2, this is for public subnet 3. So these 3 public subnet will be attached to our route table, and route table says route all the traffic to the internet gateway, and there we have created the internet gateway also. Okay, so this should create a VPC. Let's save this and let's test it. Terraform init first thing. Okay, that's done. Let's do Terraform validate. That's a success, and let's do Terraform format so we have it properly formatted. Okay, let's check its plan. Terraform plan. Okay, it has planned to add 12 resources. And what are we waiting for? Let's do it. Terraform apply. Okay, that completed successfully. So 12 resources is updated. If we wish, we can really go to the console and we can check ourselves. We can go to VPC. Or VPC. There, Dove VPC. Right, the CIDR. That's so nice. Details, DNS hostname enabled, DNS resolutions enabled. Should have 6 subnets. There we go. 3 public, 3 private. Should have the internet gateway. Dove internet gateway. Route table for public subnet, and we should see our 3 public subnet associated over here. And also the route, which points to the internet gateway. If you wish, you can create the NAT gateway, but we are going to do anyways that in the project. Okay, the next resource that we are going to create is security group. So let's go to the documentation, AWS_security_group. This should be in the VPC section. There, it's in the VPC section, not the EC2 section, because security group really is the part of your VPC. You have the example, resource, the resource name, VPC ID you have to mention, ingress and egress. So inbound traffic and outbound traffic. Mostly we keep outbound as open to everyone. So traffic from our instance can go out on any port, on any IP address. But traffic which is coming in, ingress, there we can put some restriction. Okay, so from port here 443 to port 443, protocol TCP CIDR block. So you can mention the IP address or the range over here to allow your traffic from that port. So we'll create a security group because we're going to launch an EC2 instance and we need a security group for it now. So let's go to our Sublime. And now I'm going to create a different file. I'm not going to create it in the VPC file. I'll create a different file and name it as secgroup.tf. Oops, not there. Okay, so that is the resource, AWS security group, the name of the resource, VPC ID. So we are referring it from our this VPC. Okay, so we can refer it like that. You can create things in different files. Terraform will find it and will put it in a proper order. So when it sees it has to create a security group and there's a VPC ID here, it knows that it has to create the VPC first. Okay, so you don't need to worry about the order. But if you want, you can specify order. That also we're going to see in the project. But here, the Terraform intelligence should be fine. Okay, so the name, Let's change it to Dove Stack SG. Egress outbound traffic. I'm gonna say for all the ports, traffic can go anywhere on any IP address. Ingress, although I'm gonna say 22 allowed from, I'm gonna say my IP here, but I'll put a variable better, var dot my IP, and I'll define that variable in my vars file. Variable, and I'll find my IP and put it over there. And let me see if this also the security group, and let's test it. Terraform apply, or should I say first plan? Okay, I have included a new resource. So it's refreshing the state. So checking the state of VPC, right? It's good, so it's not gonna touch it again. And all the subnets and route table, it's just refreshing the state. It's checking they're in the same state. That is good. Except I need to add one resource. Everything else is good, it is saying, and that's the security group. And let's say apply. Or you know what? You can keep adding your resource and keep testing it by saying plan. If this is good, then you can go ahead and keep adding resources. So, and finally you can apply the state. Also from the previous section, remember backend, maintaining backend is very important. So create a backend.tf file, something like that, and put your backend S3 bucket. Okay, so the security group created. Next, we will launch instance using that security group and also putting in the VPC that we created. Before that, I will now start mentioning the backend state. Okay, the same bucket I'm using, just the file name I'm changing. Let me save this. Also for the provisioning, I will need the shell script. So I will copy the shell script from the previous exercise. I already have my keys. Okay, now I can write my instance.tf file. Okay, so whatever we did in our previous exercise, plus few more things. So we're creating key pair, key named dove key, and we have the public key variable there, which is actually this public key. Let's confirm that once. Variables pub underscore key dove key dot pub. That's right. AWS underscore instance resource dove hyphen will say web. That's the resource name we'll give. AMI ID it will pick up. Instance type subnet ID. So AWS underscore subnet dot dove hyphen pub hyphen one dot ID. So this is from this vpc.tf file. Right? Dove hyphen pub hyphen one dot ID is gonna return the subnet ID of this particular subnet that gets created. Key name we are saying AWS underscore key pair dove hyphen key there dot key underscore name, so it returns dove key, so it's gonna use this key. Security group ID AWS underscore security underscore group dot dove underscore stack underscore SG. Again, that resource name is from our security group file. Yeah, dot ID is gonna return the security group ID, and then some tag. Volume, also we are putting EBS volume. It's gonna be an extra EBS volume. So some name of the resource, availability zone, we have to change this to var dot zone 1. Now our instance is getting created in zone 1, right? This subnet, public 1 subnet, in the VPC section, if you see, this is in zone 1. So our EBS volume should be also in the same zone. Right? In this case, this variables comes very handy, so you can use same variable. Right? So we create a volume there with 3 GB of size, and another resource, AWS underscore volume underscore attachment, will attach our volume ID, right? That is coming from there, and the instance ID, which is going to come from our instance. And finally, output public IP, that's the name and the public IP from our attributes. Okay, so we're actually using everything from first to fifth exercise, everything in the sixth exercise, plus many more things like VPC security group. So you're actually witnessing multiple resources distributed into multiple files and how to bring them together. Bringing two resources together, remember a resource type, resource name, dot, and the attribute name. So ID or key name, whatever is the attribute, right? That's how you club in two resources together, or you refer one resource from the other resource, right? Multiple resource, you need few more things with this, like elastic IP. You can just check the documentation how to create elastic IP and then attach the elastic IP, right? Like we created EBS volume and then we attached, and like in VPC we created route tables, right? And then we have attached the route table, associate route table. So like that, we create a resource, associate a resource, right? And for reference we use this way. Okay, let's finally test this. First we have to say Terraform plan. Now first the validate, the syntax should be validated. Okay, we have validation error because we are not referring the right names. Okay, so let's check that and let's fix that. There, if we see, we have referring AWS underscore instance dot dove. So what's the name of our resource? Dove hyphen web. And over here we have given dove hyphen dove. So let's fix that. There, also there. Let's find, we have dove anywhere. Okay, it's not there. Good. Okay, let's check once again. All right, it's a success now. Okay, let's do an FMT format because it's really a lot of things, man. It gets formatted very nicely. Okay, I love this format option from Terraform. It just makes the code very readable. Okay, Terraform plan. So we have included backend, but we have not initialized it. Okay, so we have to set Terraform init, so the backend will be initialized, because so far we were maintaining state locally. We updated, so we're gonna say yes. Do you want to copy existing state? Yes, copy. Okay, so in the middle also you can include the state, right? But then you have to say Terraform init. Okay, Terraform plan. Okay, everything seems to be good. Let's finally now apply it. Okay, that completed successfully. Let's just check it. We already checked our VPC. Let's check our EC2 instance now. Okay, that's our EC2 instance. It should be in a separate security group that we created. Yes. And also with an extra volume of 3 GB size, and it's attached. We're able to attach because it's in the same zone as our instances. Our instance is in US East 2A, so as our volume should be also in US East 2A. Yes, there. Okay, finally, once you're done verifying everything, just destroy your resources. It's easy to create, easy to destroy. I love this. Alright, so that should give you quite a good experience on how to use Terraform to do your cloud automation and how you can maintain the state as well. Feel free to check the documentation and try a few extra things like load balancers, RDS, or Elastic Cache or RabbitMQ. In the project video, I will show you how you can set up the entire stack of a vProfile. As the project that we did, vProfile refactoring or re-architecturing, where we used RDS, Beanstack, Elastic Cache, ActiveMQ, and all those services that we used in that project. We are going to automate that entire stack with Terraform and also will maintain its state through Terraform. That we'll see in the project video. That's all in the introductory session of Terraform. Thank you very much. I'll see you in the project video.